The story begins on a damp morning in November 2025 at the Autopolis circuit in southern Japan, where a Toyota GR Corolla sat in the pit lane with its hood open and a small
ブー
group
ス
of
ト圧を確認
engineers
してく
leaning
れ。
over its
了
engine
解、
bay.
13ピースサ
The
イダ
car
ー。
looked,
イン
at
タークー
first
ラーのホース
glance,
に亀裂があ
almost
る。
ordinary.
デ
It
ータロ
wore
ガーで
the
確認し
angry
よう。
red
交
and
換部
white
品を手配さ
livery
れ
of
ます。
Toyota's Gazoo racing division and carried the scars of a long endurance season. But the fuel running through its lines was not gasoline. It was liquid hydrogen, chilled to roughly 253 degrees below 0 Celsius. And the engineers were troubleshooting a problem with the fuel pump that had cost the team several laps earlier in the weekend. This was the final round of the 2025
圧力値
Super
がまだ
Taikyu
低い。
series,
もう一回トル
and
クを確認
inside
して分
the
かった。
engine
規
bay
定値の
sat one
35
of the
などで
most
締め直す。
ambitious applied
それで
research
またテ
projects
スト
in
だ。
the modern
次は大
automotive
丈夫なは
world.
ずだ。見
It
てく
was
れ。
also, in a way that very few of the people watching online would understand, the real story behind the rumor that had begun circulating that summer about a Toyota engine that supposedly ran on water. The rumor itself was almost a year old by then. It had started, as these things often do, with a misread press release and a video thumbnail. A patent filing, a fact-check article by Forbes, a fact-check article by AFP, a fact-check article by the Australian Associated Press, all confirming that no, Toyota had not built a car that ran on water. None of it mattered. The story had momentum. It traveled through social media and headlines that grew more confident with each retelling. Toyota's CEO had supposedly announced the end of electric cars. A new water engine was supposedly about to render Tesla obsolete. A revolution was supposedly being suppressed. And somewhere underneath all of it, almost forgotten, was the actual engineering work being done on that damp morning in Autopolis, which was both less dramatic and considerably more interesting than the rumor it had inspired. To understand what is really happening inside Toyota and what is not, it helps to separate three different technologies that the public conversation routinely confuses. The first is the hydrogen fuel cell, which powers the Toyota Mirai, including the lightly refreshed 2026 model that the company continues to sell in California and parts of Japan and Europe. A fuel cell is not an engine in the traditional sense. It is an electrochemical device that combines hydrogen gas with oxygen from the air to produce electricity, with water vapor as the only byproduct. That electricity then drives an electric motor, which means the Mirai is, mechanically speaking, an electric vehicle. It simply carries its energy in the form of compressed hydrogen rather than in a lithium-ion battery. The second technology is the hydrogen combustion engine, the one in that GR Corolla at
This transparency
Autopolis.
view shows the
This is a
Toyota
more
Mirai's
conventional
innovative
machine.
layout. Compressed
Hydrogen is
hydrogen tanks
injected
under the
into
rear
a
seats,
cylinder,
a fuel cell
compressed
stack
by a
under the hood,
piston,
and a compact
ignited,
electric
and the
motor driving the
resulting
front wheels.
expansion turns a crankshaft.
This is the
in same
hydrogen
way it
combustion
would in a
engine from the
gasoline
GR
engine.
Corolla.
The exhaust,
Custom hydrogen
again,
direct
is
injectors
mostly
enable
water
clean,
vapor,
efficient
along
power,
with small amounts
paired
of
with a
nitrogen
turbocharger for
oxides formed
optimized
from the high
performance.
combustion temperatures. This is the technology Toyota has been refining in motorsport since 2021, first with gaseous hydrogen and more recently with liquid hydrogen, which is denser and allows for longer range between refueling stops. The third technology, the one that does not actually exist in any practical form, is the so-called water engine. This is the rumor. It describes a vehicle that supposedly carries a tank of water, splits that water into hydrogen and oxygen on board using electricity, and then burns the hydrogen to power itself.
Pressure is stable,
The reason
flow
this
is good.
technology does not exist,
Copy that.
and the
Monitoring for
reason
leaks.
no credible
Vapor is
engineer
venting
at
as
Toyota
expected.
or anywhere else is
Confirmed.
claiming to have
Keep
built
monitoring
it,
the frost.
is that it
This
violates
arrangement
the
demonstrates
basic
fluid
accounting of
principles.
energy.
The tank holds
Splitting
plain water
into
connected by a
hydrogen
hose to
and
the engine
oxygen
block.
requires
Observe the
more
gentle
energy
bubbling. This
than you
suggests
get
a controlled
back when you
low-pressure flow of
recombine them.
mechanical and
This is
fluid
not an opinion.
interactions.
It is the first law of thermodynamics, and it has been understood since the 19th century. The electricity needed to perform the splitting has to come from somewhere. And if that somewhere is a battery on board the vehicle, you have built a heavy, complicated, inefficient electric car that is worse in every measurable way than simply driving the electric motor directly from the battery. This is the same wall that broke Stanley Meyer in 1996. Meyer was an Ohio inventor who claimed for years to have developed a water fuel cell that could power a dune buggy across the United States on 22 gallons of water. He sold dealerships. He gave demonstrations. He attracted investors. And when two of those investors took him to court, an Ohio judge examined the device, listened to expert testimony, and ruled that Meyer had committed gross and egregious fraud. The technology did not work because the technology could not work. Meyer died 2 years later in a restaurant parking lot of what the coroner determined to be a cerebral aneurysm. His followers preferred a different explanation, and the legend of the suppressed water car entered the slipstream of internet folklore, where it has remained ever since, resurfacing every few years under a new corporate logo. In 2024 and 2025, that logo was Toyota. What Toyota actually patented, and what Forbes carefully untangled in its June 2025 explainer, was something much more specific. The patent described a method of using water to cool a hydrogen combustion engine, taking advantage of water's high heat capacity to manage the unusually hot combustion temperatures that hydrogen produces. The water was not the fuel. The water was the coolant. But a patent filing with the words hydrogen and water in close proximity was enough, in the current media environment, to generate millions of views across YouTube and TikTok, almost none of which mentioned the actual content of the document. The strange thing is that the real story, the one obscured by the rumor, contains more genuine engineering drama than the invented one. Toyota has spent the past 4 years pushing hydrogen combustion technology through one of the harshest development environments available, 24-hour endurance racing in circuits like Fuji and the Nürburgring. The reason for choosing motorsport, as the company's engineers have explained in interviews, is that racing compresses years of customer use into a single weekend. Problems that might take a fleet of test cars a decade to surface appear within hours under racing conditions. Vibration failures, fuel pump cavitation, cryogenic insulation degradation, hydrogen embrittlement of fittings, all of these have surfaced and been addressed, sometimes mid-race, with the next iteration of the part being three-dimensionally printed overnight and bolted on for the morning session. The shift from gaseous to liquid hydrogen was particularly demanding. Gaseous hydrogen at 700 bar of pressure is well
This side
understood.
profile of the Toyota
Liquid
Mirai
hydrogen at
reveals its
minus
internal
253 degrees
The fuel cell
Celsius
stack
is
is
closer
located
to
under the
rocket
hood.
fuel than
The
to
compressed
anything that
hydrogen
has
tanks are stored
historically
beneath the
existed
rear
in
seats.
passenger vehicles. The tanks must be vacuum insulated. The pumps must operate at cryogenic temperatures without seizing, and any heat that leaks into the tank causes the hydrogen to boil off, which must then be safely vented or recaptured. The 2025 season saw the liquid hydrogen GR Corolla complete its best Fuji 24 hours run to date, a meaningful milestone, and also encounter new failure modes at Autopolis that the engineers were still diagnosing as the season closed. Around the same time, in February of 2025, Toyota unveiled what it called its third-generation fuel cell system, designed primarily for commercial vehicles. The new system is roughly twice as durable as the previous generation, with a lifespan now comparable to a heavy-duty diesel engine, and offers approximately 20% improved fuel efficiency. These are not the kinds of numbers
This
that
demonstration
generate
shows a
viral
clear water
headlines,
tank
but they are
connected
the
to a
kinds
simple
of
engine
numbers
block.
that determine whether
Observe
a
the gentle
technology
ripples on the
survives
water's
in real
surface,
markets.
highlighting the
A
mechanical
trucking company
connection in this
replacing a
conceptual
fleet
setup.
does not care about disruption narratives. It cares about cost per mile, maintenance intervals, and resale value. The third-generation system is Toyota's attempt to make hydrogen competitive in those calculations for long-haul trucks, port equipment, and stationary power applications. This brings us to the question the rumor never quite asks, which is what hydrogen is actually for. Battery electric vehicles have, over the past decade, become extraordinarily good at the task of moving people short and medium distances on personal trips. The combination
Check
of
out
home
this fuel
charging,
system I built for
falling
the
battery
buggy.
costs, and
It's an
steadily
unconventional
improving
setup,
fast
but it gives a
charging
real power
networks
boost.
has made the electric
The
car
whole
a
thing runs
credible
on a custom
mainstream
mix I
product in
developed.
nearly
It's been a
every
game
developed
changer.
market. The growth curves, even in the slowest adopting regions, point in one direction. Toyota's own chairman, Akio Toyoda, has suggested that battery electric vehicles might eventually settle at around 30% of the global market, a prediction that has drawn considerable criticism. But the broader point, that batteries will likely dominate without monopolizing the future of transportation, is shared by many serious analysts. The remaining 70%, in Toyota's framing, is where Toyota's multi-pathway strategy lives. Hybrids for markets where charging infrastructure is poor or electricity is expensive. Plug-in hybrids for buyers who want electric daily driving with combustion backup. Hydrogen fuel cells for commercial fleets where refueling time and payload matter more than purchase price. Hydrogen combustion for niches where engineering heritage, sound, and the existing manufacturing base of pistons, crankshafts, and machining centers provide a meaningful advantage. Synthetic fuels for regions where liquid fuel infrastructure already exists and cannot be replaced overnight. The strategy is not a rejection of electric cars. It is a refusal to bet the company on a single technological pathway. Whether this strategy is wise is genuinely contested. Critics argue that Toyota is hedging itself into irrelevance, splitting research budgets across too many platforms while competitors like BYD and Tesla concentrate their resources on the technology that is clearly winning. They point to the slow sales of the Mirai, the limited hydrogen refueling network, and the persistent cost of green hydrogen, which in 2026 still ranges from roughly $2.5 to $5 per kilogram unsubsidized,
Telemetry
well
confirms the
above the
fuel
level
pressure
at which
anomaly.
it can compete
Agreed.
with grid
Notebook logs
electricity
align.
on a cost
Circuit
per mile
diagram shows
basis
no
for
faults. It's
personal
the pump.
vehicles.
Look at this
They
damage.
argue that
Metal
every year
fatigue.
Toyota
Right. New
spends
specs needed.
defending hydrogen passenger cars is a year it falls further behind in battery technology, software, and the manufacturing scale needed to compete with the new Chinese giants. Supporters of the strategy counter that the energy transition is longer and messier than the most aggressive forecasts suggest. They point to the strain that mass battery electric adoption is already placing on electrical grids, the geopolitical concentration of lithium and cobalt supplies, the difficulty of decarbonizing trucking and shipping with batteries alone.
This is a
and the historical
cryogenic
pattern
liquid
in which
hydrogen tank,
transitions
shown in
core
cutaway view.
infrastructure
The outer
tend to
stainless
take
steel
50
shell,
years rather than
inside,
10.
multi-layer
They note
insulation
that
surrounds the
hydrogen,
inner pressure
whatever its
vessel, which
limitations
holds
in
the liquid
passenger
hydrogen.
cars, is almost certainly going to play a major role in industrial decarbonization, in fertilizer production, in steel making, and in long-duration energy storage, and that an automaker position in that ecosystem has options that a battery-only competitor does not. Both views contain real arguments. Neither view is captured by a headline about ending electric cars. What the rumor distorts, more than anything else, is the texture of how technological change actually happens. The image promoted by viral content is one of sudden disruption, of an old order overthrown overnight by a single breakthrough. The reality, visible in any honest examination of automotive history, is one of overlapping technologies competing for decades, each finding its niche, each gradually losing or gaining ground as costs, materials, and customer preferences shift. Diesel did not end gasoline. Hybrids did not end internal combustion. Electric vehicles are not ending combustion overnight, and hydrogen, in whatever form it ultimately succeeds, will not end electric vehicles. The future of transportation, almost certainly, is plural. There is a quieter lesson in the water engine rumor, one worth taking seriously. The audiences who shared those headlines, who watched those videos, who believed even briefly that a clean miracle fuel was being suppressed by hostile forces, were not foolish. They were responding to a genuine intuition that the public conversation about energy and transportation is often shallow, that the choices being made on their behalf are not fully explained, and that the people making those choices do not always have their interests at heart. That intuition is worth honoring.
As the piston
The
nears
way to
top
honor
dead
it is
center,
not to
the
replace
compressed
one
hydrogen
shallow
and air
story
mixture
with
is
another,
ignited.
but to spend the time
This creates
required
the
to
controlled
understand what the
combustion
engineers are actually doing, what the physics actually permits, and what the trade-offs actually look like when written down honestly. On that damp morning at Autopolis, the engineers eventually closed the hood of the GR Corolla, started the engine, and sent the car back out onto the track. It completed the session. It did not win the championship. It did not end electric cars. It did something smaller and more useful. It survived another race weekend on a fuel that, 10 years ago, no one believed could power a competitive endurance car at all. The exhaust, as the car accelerated down the pit straight, left a faint trail of water vapor in the cold morning air. It was, in its way, exactly what the rumor had promised. It was also, in every way that mattered, something else entirely.